This module introduces learners to the understanding of robotics, and at the completions of the modules, learners should be able to define a robot, list and explain some example of robots, explain the three major components that made up a robot, differentiates between non-programmable and programmable robots. Module summary. Definition of a robot. So far, there has not been an actual or standard definition of a robot. These is because different writers or individuals have defined robot in different terms, but yet there is always a connectivity in the definitions. Amongst some of the definitions are some as stated below. A robot is defined as a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or specialized devices through various programmed motions for the performance of a variety of tasks. Robot Institute of America, 1979. A robot is defined as an automatic device that performs functions normally ascribed to humans or a machine in the form of a human. A robot is defined as a reprogrammable manipulator device. British Department of Industry. A robot is a machine programmed to execute a complex series of actions automatically based on the algorithm in which it was designed and programmed. The pictures below show some examples of a robot. A robotic arm with 4 degrees of freedom, DOF, refers to a mechanical arm that can move in 4 independent ways, allowing it to perform a variety of tasks within a specific range of motion. Each degree of freedom corresponds to one independent movement or axis around which the arm can rotate or translate. Here's a detailed explanation. 1. Understanding degrees of freedom, DOF. Degree of freedom. In robotics, a degree of freedom is the number of independent movements a robot or a robotic arm can perform. This includes rotational movements, about axes, and translational movements, along axes. 4 DOF in a robotic arm. A robotic arm with 4 DOF can move in 4 different ways, usually involving combinations of rotation and translation. These movements allow the arm to position its end effector, like a gripper or tool, in various locations and orientations within its workspace. 2. Typical movements of a 4 DOF robotic arm. A 4 DOF robotic arm typically has the following movements. Base rotation. First DOF. Description. The entire arm can rotate around the base or pedestal. This movement is akin to swiveling around a vertical axis, allowing the arm to cover a circular area around its base. Axis. Rotation around the vertical Z-axis. Function. Enables the arm to position itself to work in different directions. Shoulder movement. Pitch. Second DOF. Description. The shoulder joint allows the arm to move up and down, similar to raising or lowering your arm from your shoulder. This movement is around a horizontal axis, usually in the vertical plane. Axis. Rotation around the horizontal x-axis. Function. Adjusts the height of the arm's end effector, enabling it to reach different vertical positions. Elbow movement. Pitch. Third DOF. Description. The elbow joint allows the arm to bend or extend, similar to how a human elbow works. This movement is also around a horizontal axis, typically in the vertical plane. Axis. Rotation around another horizontal axis, often parallel to the shoulder joint axis. Function. Extends or retracts the reach of the arm, allowing it to reach further or closer to the base. Wrist rotation. Roll. Fourth DOF. Description. The wrist joint allows the end effector, such as a gripper, to rotate around its axis, enabling the arm to twist objects or change the orientation of the tool. Axis. Rotation around the longitudinal y-axis, or a similar axis depending on the design. Function. Allows the end effector to be properly oriented for tasks. Mobile robot. A mobile robot is a machine that can be controlled by help of a software that uses sensors and other technology to identify its surroundings and move around its environment. Mobile robots can function using a combination of artificial intelligence, AI, and physical robotic elements, such as wheels, tracks, and legs. Nowadays, mobile robots are becoming increasingly popular across different business sectors and are used to assist with work processes and even accomplish tasks that are impossible or dangerous for human workers. Mobile robots can also be divided into 2 main types, autonomous and non-autonomous, or guided, mobile robots. Guided mobile robots. These are robots that require some form of instruction or guidance system in order to move. Autonomous mobile robots. And autonomous mobile robots, AMRs, are type of robots that are able to move and explore their surroundings with the help of sensors and does not require any sort of external direction. Also, AMRs differ from autonomous guided vehicles, AGV, because AMRs possess the ability to be more independent. AGVs typically require external guidance, such as magnet strips, wires, or sensors installed in the environment's floor, thus creating an inflexible system that is both expensive and difficult to adjust as needs change. AMRs aim to overcome these obstacles by requiring little to no external guidance. Explanation of the three components that made up a robot: sensors, actuators, controllers. Sensors. A sensor is a device that has the ability to measure the physical input from its environment and converts it into data that can be interpreted by either a human or machine. Most sensors are electronic. The data is converted into electronic data. But some are more simple, such as a glass thermometer, which presents visual data. People use sensors to measure temperature, measure distance, detect smoke, regulate pressure, and a myriad of other uses. The below pictures are some examples of commonly used sensors in robotics. Microcontrollers, microprocessors. Microprocessors are compressed microcomputer manufactured to control the functions of embedded systems in office machines, robots, home appliances, motor. The microprocessors can also be seen as the brain of the systems that is responsible for interpretations of information. It works just like the human brain. The below pictures are some examples of commonly used sensors in robotics. Actuator is an electromechanical device that produces a motion by converting energy and signals going into the system, and the motion it produces can be either rotary or linear. Linear actuators, as the name implies, produce linear motion. This means that linear actuators can move forward or backwards on a set linear plane, a set distance they can travel in either direction before they must stop. Rotary actuators, on the other hand, produce rotary motion, meaning that the actuator revolves on a circular plane. Unlike the linear actuator, the rotary actuator is not limited by a set path, which means it can keep rotating in the same direction for as long as necessary. Differences between non-programmable and programmable robots. Non-programmable robots is a robot that does not have a brain, and as such, it cannot store and execute any form of coded instructions. Example of this kind of robot is the cardbot robot made from pieces of cardboard. Differences between non-programmable and programmable robots. Programmable robots is a robot that has the ability to accept and execute a set of coded instructions stored in its brain. The brain is made up of an electronic device called a microcontroller. End of module summary. Definition of a robot. A robot is a machine programmed to execute a complex series of actions automatically based on the algorithm in which it was designed and programmed. List and explanation of some examples of robots. The robotics arm. A robotic arm is a type of mechanical arm that is designed to look like the human arm. It has various segments which closely resemble the shoulder, an elbow, and a wrist. A robotic arm is programmable and can be directed to perform a variety of functions just like the human arm can. Mobile robot. A mobile robot is a machine that can be controlled by help of a software that uses sensors and other technology to identify its surroundings and move around its environment. End of module summary. Explanation of the three components that made up a robot. Sensors. A sensor is a device that has the ability to measure the physical input from its environment and converts it into data that can be interpreted by either a human or machine. The microprocessors can also be seen as the brain of the systems that is responsible for interpretations of information. It works just like the human brain. Actuator is an electromechanical device that produces a motion by converting energy and signals going into the system, and the motion it produces can be either rotary or linear. Differences between non-programmable and programmable robots. Non-programmable robots is a robot that does not have a brain, and as such, it cannot store and execute any form of coded instructions. Example of this kind of robot is the cardbot robot made from pieces of cardboard. Programmable robots is a robot that has the ability to accept and execute a set of coded instructions stored in its brain. The brain is made up of an electronic device called a microcontroller.